Hello and welcome to a lesson on reviewing completing the square. This won't cover the details per se, but it does go through and remind you of material covered in Algebra 1 and Algebra 2. One of the key features of completing the square is knowing numbers that you're looking for. And so you're going to want to get yourself familiar with perfect squares. Some of these are easier to remember than others, but they come up frequent enough that it's worth having them ready to go. For example, if you look at a problem like x minus 3 squared, we're just going to start with a binomial and square it. The binomial squared is x minus 3 times itself, which turns into an x squared, a minus 3x, and another minus 3x. That's a total of a minus 6x, and then a plus 9. And what you start to realize is this number doubles, goes in as a coefficient of the x or linear term. This number squared becomes the constant. And our goal is to be given something like this and turn it back into that type of a binomial squared. So we reverse the process of multiplying in order to complete the square. And since the linear term's coefficient is doubled, that thing, it comes from a 3 and a 3. So we're going to want to cut that thing in half. Likewise, to make a perfect square, we need to add in the constant, and that comes from last times last, in this case 3 squared, which is going to be 9. So some of the familiarity you have with numbers is going to be useful. For instance, you might know that x minus 5 squared gives this. The way to find the perfect square binomial that goes with this trinomial is cut the constant for x in half, and also take that and square it, or in this case square root the c, and you'll find your binomial. So for instance, we're going to want half of this 12, which has to equal the square root of 36. The answer is x plus 6 squared. Try this one on your own. Notice the negative. Okay, half of negative 2 is negative 1, and the square root of 1 is 1. So we get y minus 1 squared. Notice you're always going to have a positive number there on the c. Try these on your own, see if you can get them. Do the first two. I'll go over something on the last two. All right, we did this one already. This has to be a 25 because if we take half of the 10 and square it, that becomes a plus 5. Likewise, this negative might mess you up a little bit, but half of negative 12 is negative 6. Negative 6 squared is positive 36. Now when we deal fractions, and we are going to run into some of those, there's two ways to look at how to cut things in half. If the numerator is even, you can just take half of the numerator, in this case 1/7, and then square it. This is 1/49. If you don't have an even numerator, just double the denominator. In this case, 5/14 would be half of 5/7. So 5/14 is going to be 25 over 196. Again, remembering those perfect squares is helpful. That creates a perfect square of 5/14, x plus 5/14 squared. All right. I'm not going to do all of these, but do 1, 5, and 7. See how that goes. Okay, half of 8 is 4. Squared is 16. That's a plus 4. And this is going to be our goal, is to create this perfect square. Half of negative 24 minus 12. That means we needed to add a 144 to make a perfect square. Come down here. A little bit annoying. 9 is not an even number. So you'll have to cut that in half and square it. Use that information for this one. And number 7 there. See how that goes. Okay. Half of 9 is just 9/2, gives you a positive 81 over 4, and a minus 9/2. And I suppose I should erase those divided bys. Now, in this case, number 7, it's a little bit easier. You can take the numerator, cut it in half, that's 1/5. So that means we must add a 1/25. If you'd like to practice the ones on the right, might be worth it. I'll just go ahead and give you the answers without explanation, and you can follow up with questions when you're in class. And now we move on. And now we will consider problems where the leading coefficient is not 1. And as I do these, I use square brackets to show factoring out, and then parentheses for the completing the square work. So for instance, in this case, we'll just look at our variable terms and factor out a 3. And we always need to have our coefficient of x squared equal to 1. So if I factor out a 3 and use square brackets, I get x squared plus 8x. I'm going to leave a little bit of space in there. This x squared plus 8x is not a very difficult quadratic to try to complete the square. I know that I'm going to take half of my 8, square it, and add it. So half of 8 is 4, and squared is 16. Now if I've added a 16, I need to subtract a 16, otherwise I've created a different expression. And the thing I need to keep track of is that I've got a 3 to multiply. So the 3 times 16 is really what I added. I need to subtract out a 3 times 16. So this last step goes pretty quickly then. 3 parentheses times my perfect square. I do a little bit of math here. That's 48, negative 48, so minus 43. We call this vertex form. We're calling this lesson completing the square, but the work you did back in Algebra 2 dealt with something called a form of a quadratic. We could use that information to find a vertex. Let's come down here. Why don't you try this one? 4x squared plus 24x plus 1. Okay. Again, first step, factor out the 4 from the x squared and the x. Thankfully, we've got a even coefficient of x. Half of 6 is 3. 3 squared is 9. I've added a 9. I need to subtract a 4 times 9, leaving 4 parentheses x plus 3 squared. Do some work there, minus 35. Okay. There's the review of how to complete the square for a is 1 or a doesn't equal 1.